Всем доброе утро.
Good morning, everyone. Today we have the third workshop of our hackathon of Cosmos ecosystem, the first ever Cosmos hackathon in Russian, hackathon.ru 2021. Today we'll be talking about developing a decentralized DB using Tendermint. Anton Kaliev will be the one doing the presentation. Hey, Anton, can you hear us? Yeah, hi, everyone. Hey there. Now, before we start, before we dig into this, dear friends, please make sure you understand. You can ask questions as you go, as we go. So we will ask those questions at once as they come in. If something is unclear, YouTube chat, Hacker Telegram chat that you see popping up on the screen, I'll be monitoring your questions. As long as there's something urgent coming in, I'll be relaying them to Anton and he will do his best to answer. Now, if you're watching this on Cosmos Network, that most likely you're listening to the English interpretation, Russian to English. So feel free to do the same, just the same. Telegram chat, voice your questions, type your questions in English, no problem there. So without further ado, I will pass the floor to Anton. Anton, go. Right. I'm not going to be talking about the DB development. Essentially, Tendermint has a very brief manual that basically it's a super guide, and it literally takes a couple of minutes to put together a simple DB. You can pull it up on the site. Okay, so what are you going to be talking about? Well, what I'm going to be talking about is testing Tendermint. Sergey invited me and he told me that I can pick any topic, so I decided to talk about testing because this is what I've been doing the past several months. For the past several months. Now, some advanced testing techniques. Somebody, particularly Go developers, will find this useful. So these guys will benefit from it the most. But before I proceed, let me tell you what Tendermint is. Most people most likely know it, but just in case. Tendermint is a framework to build proof-of-stake blockchains with slashing. It can punish for malevolent actions, for wrongdoings. It is underpinned by the Tendermint consensus, namesake, surprise, surprise. Now, I'll briefly describe how it works. It's very simple, as opposed to Patsat or some Algorand or something more sophisticated than this. It works very simple. And every altitude, say 1, 2, 3, and every height, there is a node that is supposed to generate a block. So it collects transactions, the uncommitted transactions, it produces the block, and it then proceeds to send it to the remaining nodes using the Gossip protocol. What happens next? The participants exchange some preliminary votes, pre-votes. Also, Gossip protocol is involved, Gossip network. As soon as 2/3 plus is generated, so pre-votes for the same block, 2/3 are collected. The second round of the voting starts when there is pre-commits. Again, when 2/3 plus have gathered, the block is deemed committed, and the next iteration, the next round starts. Round 1, round 2, round 3, and so on. So what are the features here in this algorithm? It's very easy to understand, very straightforward, same as many other BFT algorithms. It's quite sustainable, resilient to less than 1/3 of Byzantine malevolent nodes. So bad guys, one third and less. So it's pretty resilient. Now, what else is there? Let me point out separately that during the first phase 1, when the prelim votes, pre-votes are exchanged, the nodes can vote for the block without even having received it 100%. All they get is a header, some kind of header with hashes. And then when they start exchanging votes, committing or not, pre-commits, the block is there, they have validated it, and now they start voting for it. So they're certain that this block is valid. Right. So one of the memes from our internal chat room. Many folks, well, not really many folks, but some designers decide to come up with their own consensus algorithm. Some of them are doing a good job at it, like Hot Stuff, and the recent thing that introduces several improvements like pipelining, optimistic pipelining, pipelining, optimistic responsiveness. It's a great thing. Tendermint, it's also going to be implemented. So just use Tendermint. Stuff to read up on. So there is white paper, the Tendermint, and code on GitHub. There is a small visualization on my website. By the way, this slide deck is available. Yeah, should have made a link to that here. Okay. Anyway, you can go to speakerdeck.com/Melikes. That's my alias on GitHub. And you'll be able to find this, to get hold of this slide deck. Now, ABCI. When nodes agree on the block, they don't really care about what's there inside the block. So the contents of the transactions is completely transparent. So it doesn't really matter what values the distributed database can be about. Could be POS, proof of stake, blockchain, anything else, you name it. Inside the block, some buckaroos, parrots. So there is the interface between Tendermint and the app. That enables Tendermint and the app to exchange data and protobuf. Thereby, you can basically write an app in any language. Golang, Java, C++, you name it. The interface is fairly simple, very simple. When a transaction comes rolling to Tendermint, say from the network, it invokes the checktx method to the app, from the app, and it asks basically, is that transaction valid or not? Is that TX valid or not? When the time comes to commit the block, Tendermint triggers the chain, init chain, begin block, deliver TX, and then block. Basically, deliver TX is please commit this transaction, saying that. It is saying that. And thus, we are changing the state of the app. Right. And at the end, the commit method is triggered. Then again, all the methods pretty well written up in the specs. They're fairly straightforward, simple. Init chain starts at the outset. When this genesis, the first block is created, query is triggered when someone requests via Tendermint API some application data, and someone requested app data. The application may have its own API, or Tendermint API can be used for the same purpose. Right, Cosmos SDK is just the same kind of application. The application using ABCI interface. Essentially, Cosmos SDK is not a full-fledged application. It's a framework that helps you build your own app. But Cosmos SDK, as many of you know, represents, it grants several ready-to-use modes, governance modules, governance, staking, and the ABC particularly, among others. Thereby, you don't have to write your own code. Yeah, basically you can hard code your app, or you can use the ABCI interface. Stuff to read up on. Again, there is the specs available. And the second link is one of the stories that I've written. You can put together a very basic database using ABCI without using Cosmos SDK. It's just pure Go plus Tendermint, crude Tendermint. Now, unless there are questions for this part, let me take you to the testing phase. Namely, like I said, the past several months I've been involved with testing on Tendermint, quite intense several months, intense testing, particularly the three last chunks of the pyramid. So initially we had unit tests, then integration tests, followed by end-to-end tests written in Bash. They were very tough to support. Nobody wanted to mess with them, those sticks. Yeah, just a bit. Then Jepsen tests came in. Now there's multiple sets of fuzzy tests, not one, but multiple, and model-based tests. Okay, I'll proceed to talk about these later on, and we will even try to code something as we speak. If someone wants to do the coding with me, like interactive stuff, please make sure you have Go installed. There is make sure you also have the Docker installed on your machine. If you don't, well, these are the instructions to quickly get it in there. The first thing we're going to talk about is end-to-end testing. It's kind of tough for me to talk about that in Russian.
Сквозное тестирование.
Right, end-to-end testing, perfect. I'm getting the new vocabulary from the interpreter here. Yes, end-to-end testing is what it is, сквозное тестирование in Russian. So like I said before, we used to have bash tests, those horrible stuff. I don't recommend this to anybody. Only if you're really forced to do the bash testing. That's the only way to do them. Then we got a new test suite that is written in Go, and it's using Docker. It's raising 4 nodes, it's launching 4 nodes, and does testing on these. You can actually write a set of tests, a batch of tests. So if you guys don't have Tendermint, clone it. Go to Tendermint /test/E2E, which is end-to-end. You can also trigger the make command to put together the images required, the Docker images. Right, let me do just that. No, I hope you can see my screen. This is Tendermint. This is the advanced directory, end-to-end directory, E2E. There's apps here, some build scripts, the Docker, namely files, Docker implementation, and basically the tests proper. Make file, there's README as well. So let's go to that directory. Let's trigger make. Yeah, some compilation is going on. Right. So essentially, the network config is written in this TONL file. It's the most basic, as basic as they come. There are 4 validators with a standard config. There is a more sophisticated configuration available, like this one here, 100 lines, and it's invoked every time that we get a pull request. When somebody creates pull request in Tendermint / Tendermint, the initial height is preset 1000, say here. How many? The 3, 4 validators, 5 validators. 5 validators. Some get killed, some get added. The stake changes. The complete file can be pulled up. Plus there are a couple seeds there. Seed 02, seed 01. Seed nodes are the nodes that act as address books, address indexes, like that help nodes find each other, get together with each other, get connected. Right, so let's write some code. Let's try to put some testing code together.
Отлично. Ну вот, у нас, например, есть...
Great. Say here, we have the test that sends a transaction commit, and then it checks whether it has been committed. And using the HTTP client, we can get it. And then the query method is invoked. I briefly mentioned it before. It checks the presence of data, the essential presence of data, the fact that the data is stored in the app. You know, the similar method. Let's put together a similar test that is also going to send the transaction. So we're going to send the transaction and then invoke the method text search, tx search. Tx search method is the one that is searching for the transaction, self-explanatory. Right, so it accepts context, the search string, the proof, whether we want proof, and some pagination parameters.
У нас используется в Tendermint свой query формат.
In Tendermint, we use our own query format, the more basic one. For example, using the TX hash key, you can get hold of your transaction. You can locate it. A certain transaction. We put in hash, put in true, nil. As pages, we can fit in nil for pages. The last one is sorting, ascending. Nice. Let's roll with that. TX search response.
Посмотрим, что у нас возвращает.
Namely, let's check out what TX search comes back with. TX search gets us the transactions and the total count. So let's check out what total count can do for us. The total count is 1. Then let's check that. TX. And then the transaction proper. That's the way the test is going to look like. That's what the test is going to look like. Let me remove this. We don't want this. That's basically it. That's the results of build. Success. All we need is to run these tests. We have the README. Running the tests. This is 4 validators launched by the Docker. And then it triggers the tests from our test folder. The test is down. Possibly I wasn't really comparing the right stuff. Right. Great. The transactions compare the response. Response. Broadcast. TX commit. Doesn't really matter. We can make it like this. $30 minutes. All right. Doing well on time. All right. So this is the test. It has been completed successfully. Everything good. So if you guys want to send a pull request to Tendermint, you can open the pull request with this code, and I think it will get accepted like that, just like that. You can become a full-fledged contributor to open source. Right, there's more to it. If somebody finds it interesting, you can play around with the configurations, with the configs. And you can try breaking down something there. These tests are not necessarily ending successfully. Sometimes, yeah, they crash. There's quite a bunch of options. You can change the DB. You can change. You can kill the node, a specific node. You can engage or disengage fast sync. What I'm saying is the config parameters of Tendermint, if you're familiar with them, feel free to change them. Otherwise, you can just mess with the numbers and see what happens. Let's move forward, unless there are questions, of course. Now the next bit, the next testing layer is Tendermint is fuzzing. Way back in the day, maybe around 2017, not that far back, one of the contributors of Tendermint put this test together. Then they were abandoned, those tests. But recently, I've uncovered that stuff, I restored it, and now every night we write, all the tests are launched. We'll be using the Dmitry Vyukov library, GoFuzz. It's very simple, the library itself, but the objective is not too complicated either. So what the fuzzer does is that it generates a set of bytes, and then it checks out whether the app crashed or didn't. Essentially, it's a bit more complicated than that, but not all that complicated. Now let's check out this function. Let's test the decoder and encoder of the PNG format, image format.
Собственно, смотрим, есть ли ошибка, если
So let's see if there is an error, errors. If there is an error, the 0 comes back.
нет ошибки, значит,
If there are none, meaning that the fuzzer has generated the PNG image we wanted,
можем ли мы его
in which case we will check whether
заинкодить.
we can encode it.
Если нет,
If not,
то падаем в спать, крашимся, если
then the test crashes,
возвращаем единичку.
panic error. If everything is fine, 1 is returned.
Нульки и единички, они
The zeros and ones
они помогают
essentially help the fuzzer
понять,
to make sense,
должен ли он, да, ну, внизу написано.
to figure out. It says in the bottom whether the fuzzer is supposed to boost the priority for this particular byte sequence, whether it's supposed to try and change the set or try and mutate it a bit and then see what happens, whether your app crashes or doesn't. The -1 can be added to completely ignore the bytes. This is the way I imagine fuzz testing. Every time I launch the fuzz testing, it's kind of a small gnome or cat sitting there, generating those bytes. Okay, let's try and put one more test together. All the tests are located in the test fuzz folder. So we're going to that directory, the text tx search method. We're making the directory RPC core tx search. Then we're writing the code proper, and we're going to launch the fuzzing. Current directory fuzz, make directory RPC core tx search. Scratch that, just RPC core, I'm making a dir here. NVIM tx search, go. Right, this is the file. You can even copy it. Copy the stuff that's in there. Package tx search. Fuzz function. Like this. Yeah. Now, let's see how we're doing on time. We have 25 minutes remaining. In that case, let's so let me think what we're going to do next. Well, like as I would have done this normally, just several days ago. I just went to RPC client. I found the test that triggers tx search. This one here. That's the one. And I literally copied that text, that code. Copy paste. As plain and simple as that. So now I'm just writing this anew, txt search, context background. String data. True, nil, nil, ascending ASC. Now, if error does not equal nil, like this, invoking panic. Return 0, otherwise everything is fine, return 1. We're going to need some additional functions. RPC client. This whole stuff, we can find it in the RPC client, all of it. So what I'm doing right now, essentially, is that I'm creating an app that is shipped together with Tendermint, one of the basic key value stores, just an in-memory DB kind of. The RPC test is one of those auxiliary methods. To put a test together, it will require some knowledge. Oh, well, at least you'll have to figure out a bit the inner workings of Tendermint. You'll need to figure that out. But that's if you want to contribute something.
Создали приложение, запустили Tendermint.
So we've put an app together, launching Tendermint, created a client. The final thing left to do here is commit the transaction.
И оставшийся метод один у нас makeTX.
And the makeTX method remaining.
txt, который у нас возвращает
make txt returns
она возвращает ключ, значение
returns the key.
значение и словную транзакцию.
Return kv, append k, append byte.
Так, осталось добавить.
Right. So we need to add something else here.
И последний TM-rand.
The last TM-rand. To generate the random numbers.
Так, ну вот он у нас тест.
Right, so this is our test. Like I said, we're creating it, creating Tendermint, creating the HTTP client, sending a dozen of transactions there. It's a meta text search, unlimited number of times. Go fuzz build. Right. First, we need to make it current directory, RPC core, go fuzz, build. App checking failed. Go fuzz build creates an archive. It creates an application. Creates a binary. I don't really know how exactly it works. But it creates some archive that is launchable with the command, fuzzgo command. Anton, a question came your way. Anton? Now it's launched. Then gradually we add. Let me tell you briefly about the stuff I know. That's the archive, the zip file. It puts into the corpus the valid sequences. Puts the valid sequences into the corpus. Also, it's possible to add to the corpus the sequences of bytes on your own, which are semantically valid. Semantically valid byte sequences. This will help the fuzzer. Now, say we can add, for example, with testing text, TX search, let's throw in TX height more or equal to 0. So we're selecting all transactions equal or higher than 0. Some reason it crashed. Yeah, namely the crashes. We'll see the input that caused the app to crash. Yeah, have a look. Yeah, it's a lot of fun. The computer does some stuff for you. And sometimes it causes detecting a couple of bugs, particularly in our case for RPC server. Using fuzzer, you can detect some bugs.
Антон, тут есть к тебе вопрос, может быть?
Anton, there's a question to you.
Да,
Maybe I've
наверное.
not written the test properly.
Ладно, перейдем, сколько я уже, 50 минут разговариваю, перейдем к следующему виду тестирования.
Okay, let's switch to the next type of testing, namely this TX search that we've just written. If you've been following me, you can also trigger it with pull request, possibly. Well, yeah, it will get accepted. The last thing I wanted to talk to you about today is Jepsen testing. Jepsen is a framework for verification. Framework for verification of distributed systems with some additional features. As the author, left-hand side on the top. What Jepsen can do for you is the first and most important feature is checking linearizability. So linearizability. And let's talk about that if you don't know what it is. There are two products, Knossos and L. L is the most recent verifier that came out recently, very recently. It can also introduce some cases into the system. So basically everything that can be done with Linux commands, it's possible. It can generate emulate network problems using IP tables, internal IP tables. It has an API, a fairly basic one at that. So it does everything on its own. It can play around with the clock. It can crash processes. It can start processes, or stop and restart them. There is visualization, there is API. The only thing it's written in Clojure, but if you're a Clojure developer, then this is going to be the top story for you. Okay, linearizability. What is that? It's one of the consensus modules. The most strict, the strictest out there. Linearizability. So many of these have been written up here already. Some of them should be familiar to you, especially to those of you who have used PostgreSQL or MySQL. So this is the extract from PostgreSQL. These are the isolation levels, transaction PX isolation levels. So basically, the consensus models, which Postgres supports, and you can configure them. There is written commit.
повторяющееся чтение.
There is read committed, repeatable reading, and serializable. The columns on the right-hand side is the kind of anomalies that you may face. For example, dirty read, it's when you're running two transactions in parallel, and one of those transactions reads the data written but not committed by the other transaction. That's called dirty reading. And there are also others that you can read up on. Right. Linearizability is when all the transactions are kind of atomary. There is a single way to introduce the story where transactions are following each other at every moment in time in a linear fashion. So how does Jepsen work? Essentially, I haven't figured it out myself 100% because Knossos does not really come with too much docs. But for L, there is a YouTube video, there is a white paper written by Kyle Kingsbury and his colleague. In a nutshell, we have a certain set of transactions, T1, T2, T3, T5, T3, T4, T5. So we have a story of execution of these transactions. What the verifier tries to do is that it tries to go into this graph. You can consider this transaction history as a graph. And it tries to find a path in the graph that makes sense. The path that makes sense in the graph. The first case, T1, T3. Wait, yeah, right. T1, T3, T2, and T4. So this is the path that is logical. In this case, all transactions will be completed in atomary fashion. In the other case, we're just cycling. It's not really clear which path is unavailable. In a simpler way, we have transactions T1, T2. Imagine that the first transaction writes a 1 to the key X. X1, Y1. Transaction 2 does the same but writes 2 and 2 respectively for X and Y. And there is transactions 3 that's implemented as well. Now the testable database brings back values for 1. So basically 2 W's on the bottom, T2, and 2 W's above on T1, the verifier. The list helps you track the changes of modifications of a specific key. Transactions 3 makes it visible. It's inconsistent execution, non-linearizable. So basically, X equals 1, the first transaction, but the second transaction was true when y was 2. Then x became 2 and y became 1. And that's one of the anomalies. Clearly, this is not the way it's supposed to be if it's linearizable. Linearizability would have meant that it's 1, 1, or followed by 2, 2, or vice versa. 2, 2 followed by 1, 1. Don't have that much time remaining, but let's check out the code briefly. I believe that quite a few folks will find it interesting how it is described in the code. We have one of the tests here that implements this model, compare. So we preset a model. We will check this out. The generator is how Jepson performs testing. It sends a whole bunch of transactions, and then it analyzes the history. Basically, the transactions to be sent are described in the generator. In this case, we're sending a mix of writing and compare set transactions and some read operations as well, read transactions as well. There's some limit preset there as well, gen limit, it's time. And the concurrent generator, that means for multiple keys, ones, twos, and not just one key at a time. Concurrent, simultaneous. X, Y, Z in our example, getting back to it. Right, then we describe the verifier itself. We tell it to check the linearizability. This is the way to describe the model. It's conventional, it's standard. It comes with Jepson, with CAS register, compare a set register. We describe the transfers which are valid and which are not. Compare a set in this case. Whoops. If the value that is fed, the compare value, is equal to the current value, everything's good. Otherwise, the return is inconsistent, which means it's an invalid transfer. It's an invalid transition. This is the way the client looks. The client is just a wrapper around the HTTP client. The read triggers the read transaction to be sent, same for write, using HTTP client, the conventional one that comes with Tendermint. All right. I'll briefly mention that there are possibilities I've talked about before. The change of network topology. I mean, clusters from machines, 5 nodes are created by default. They can be broken down in halves. Or some other options. Ring. Yeah. Not sure how to call this in Russian. I don't know whether the time permits or not. Most likely it doesn't. Well, there is time. If you want to do it yourself, you can go to Tendermint /Jepson repository. You can clone it, You can launch the Docker and bin up creates clusters and launches them in a different tab. Well, in a different tab, you're launching the Docker, the console, and then the test. Right. Again, Nadia, do we have time? Enable sound.
Не слышно?
Тебя слышно, ты нас не слышишь.
Ой-ой-ой. Не, слышно или нет? Нет?
Тебя слышно, ты нас не слышишь.
Включи. Ты нас не слышишь. Да, я вас не слышу. Сейчас.
Юр, ты на русской дорожке.
Okay, let me try and fix the sound issue because I can't seem to hear you.
Теперь Антон, похоже, ты отключил свой
No.
голос.
Anton, I think you've muted yourself. Nope, it's there. Can you hear us now?
Нет, видимо, нет.
No, I don't think so. We can hear him, but not the other way around. Bear with me.
Говори.
Ой-ой-ой.
Чат!
Questions.
Да, есть.
Yeah, there are recommendations, there are guidelines, all the protocols. So my browser is not shared, but all the protocols are available in the Tendermint/spec Tendermint/spec repository. There are specifications for some chunks of code. There are extended specs, the ones used for formal verification. Well, that's beyond standard documentation. There is standard documentation for development, and there is more in-depth kind of stuff, particularly for testers, for more profound understanding. Modular tests. Do developers themselves cover their own written code with unit tests, or do individual people cover? TDD, do you practice that? No, I don't practice TDD. We do that whenever we write a new feature or fix a bug. We write a test. I don't think it's called TDD, but the question is, how do we write the test? Modular tests. The developers themselves, do they cover their own code with unit tests? No, they do. They do cover it. Individuals as well. I mean, specific people. Our product is fairly popular. 4,000. So from every now and then, contributors come rolling. Right. Okay, so let's give Anton some time to reconnect his earphones. For some reason, we can hear him, but not the other way around. Let me recheck the questions. There were two that came in the chat box. We've voiced them already. as far as I've gathered. Fork log. On fork log, there are no questions. There was just one question. What kind of editor are you using?
Думаю, что он ответит, видимо, на него позже. Да, ты все слышишь.
No, I can't hear you. I can hear you now. So which editor were you using? What's the editor you've been using? Vim. I'm the old school guy. Okay, no more questions. If you have something to add, please do so now. Or you can make a summary or something. What to look for, because, well, just several words of summary to wrap up our workshop. The floor is yours. Back to you. Yeah, make sure you're unmuted. Well, it's on. It's all right. No, yeah, now I can see you're unmuted. Okay, so we can launch Jepsen. It's a fairly cool toy if you wrap your head around it. Clojure developers should find an easier time doing that. Yeah. Let's hit the Jepsen folder.
Есть всякие редмишки. Ну, да, давайте попробуем запустить.
Right. Let's try and launch Jepsen for starters.
Скорее всего, Кайл, автор вот этого Jepsen, использует другой lin.
Most likely this file is using a different lin. So everything is working in that case, but not in this case. Okay, forget it. Right, so Jepsen is up. 5 nodes, Debian, Java, and Clojure inside.
Тоже зайдем в папку Docker, запустим консоль.
Current directory Docker, launching console. The console says that now can run the test. Full 4 folders: Docker, Jepsen, Merkleize, and Tendermint. Merkleize is the special purpose app read transaction. Why do we want it? We want it specifically to that end. If you want to check linearizability. Essentially, linearizability is too strict a function, too strict a model.
Строгая, да, модель.
That's right. Too stringent a model, too strict a model. In many cases, you can select something less strict than that. For example, reading not via transactions, reading can be performed via HTTP server, the common API. It's not too bad if the API returns a bit obsolete data. Well, not really obsolete, but not the most recent ones. The end of the world is not going to happen. The world is not going to end there. So this is the app, some kind of in-house app written there. There was also a question. I did a similar presentation on Jepsen for my colleagues. The question that came from them was, can you use a different app to test linearizability? No, you can't. Mostly this gizmo is for Tendermint to check that the system is functioning well, that the system can perform these guarantees if need be. It's a thing to test the consensus app and the framework itself than for testing the applications. But if you want to, yeah, of course you can use it, but I wouldn't recommend that. Right, we can run the test. Which test? Just a plain one. Alternatively, we can when I was preparing for this presentation, I also found that there is Jepsen API when I was putting the slide deck together. There is a script, Nemesis, a scenario that brings in some conflicts. And you can also add additional stuff, partition and random halves. Partition random halves. This is random halving that's used here, but Jepsen also has just half partitions, which you can just remove. Random, and it will just say partition halves. You can add yet another scenario, commit it, and yeah, this will happily play for you, partitions. Now the test is being performed. There are some parameters that it shows us, some SSH thingies, the archive used for testing, the binaries, binary Tendermint and binary app. Then it returns, yeah, basically that's how the clusters themselves start, and 1 through N5, different order. We download the binaries, the configuration of our nodes is returned, some public private keys, 5 nodes again. Then creates Genesis, writes Genesis.json, the file. It starts Tendermint, it starts the app, standalone apps, and it starts generating the transactions. Read transactions, write transactions, compare set transactions. And as I mentioned before, the frequency can be changed. More transactions, fewer transactions in a specific time frame. The only thing, if you're doing more transactions on a local machine, the verifier itself might get crashed with out-of-memory error, because the analysis task is an NP complete. Well, the task itself, but it's a bit more complicated than that. This verifier is narrowing the space of the story, and there are certain optimizations run to make sure that the story, that case is analyzed execution story history is analyzed in a reasonable amount of time. If everything is fine at the end, everything looks good, yay. Okay, a summary, right? To summarize, well, that's basically what I'd like to show here. This is there's fuzzing, fuzzy testing, there's model-based tests. Informal systems command writes the body and the class of the specification, the body and the class. This is the language for formal verification. I think I mentioned that. We describe the algorithms, then the REST instrument generates and then these tests are used to test the Go part, the Go implementation and REST implementation. I don't know if I made myself clear, but on Medium there is an article for that. You can read it to figure out how it works more properly. Now, what do we plan to use? Our further plans for testing, property-based testing. So there are so many plans, there are so many tasks. We want to add property-based testing. So if you guys got inspired, if you're enthusiastic about it, if you're passionate, if you want to work for the European startup, that's the website for you to check out, jobs.cosmos.network. We give options in atoms. They are worth quite a bit these days, well, compared to the baseline price. Okay, thank you. Yeah, indeed, these puppies are more valuable day in, day out. We also have prizes in atoms, and atoms are in high value these days, as Anton has said. So guys, please make sure you participate in the hackathon. Anton, thank you so much for the workshop. Go to the chat room with hackers. The questions might be popping up there if somebody watches this in the recording. So guys, please feel free to participate in the hackathon. Check out our website, check out the prizes, the bounties, huge prizes, various nominations. Hackers and humanities people can participate. Well, not necessarily humanities people, because we have reopened our prize for translating technical documentation into Russian. We've opened that bounty before the hackathon, but since a lot of documents are still to be translated, this contest has been reopened. If you want to, if you can do technical translation from English into Russian, feel free to apply. There's also good stuff for you, some goodies for you to compete against for. So Valery Litvin will do a workshop later, Cosmos and contracts development. Thank you.